All right, all right, all right. There's a notey that I went live. Let's see how we're looking. Okay, looking good. All right. Well, let's get this ball rolling so we can get done. So what I did is I took a AP practice exam from 2019, and we're doing the multiple choice. And what I did is I went through and tried to give each student a hint. So what you want to do is try and pause it maybe. Try the problem, pause it. Then after you're done, pause it, check in the hint, see if you did that. Then pause it, and then watch the solution. So whatever you need to do to benefit your life and your studying habits for the AP exam is up to you. Just my beautiful face. Okay, let's try that. All right, that's fine. So anyways, we're doing the reverse power rule. The first thing we want to do is pull out the coefficient, so that we only are looking at the reverse power rule. And the reverse power rule says if we're going to integrate, what we're going to do is we're going to add 1 to the exponent and then divide by that number, whatever it is. If you have a constant, you bring it down. We're going to multiply. And what ends up happening is we get 1 over 12 x to the third plus c. Look at this. Boom. B is our answer. Remember, questions, throw them in the chat. I think I have my noties on. If you want to comment in the Discord chat, you're welcome to do that as well. I'm looking at my Twitch stream chat. Just let me know if you have questions or you want something clarified. All right. Well, let's try the second question. So once again, read through the question. So which of the following is an equation for the line tangent to the graph of y equals cosine x at x equals pi over 2. So they're giving us this. Then what we're going to do is, you can pause it, try it. Then we're going to look at the cheat, which is y minus y1 equals dy over dx, x minus x1. So we have the point slope formula. Well, 1 equals dy dx, x minus x1. If we're trying to do the line of tangency, this is the equation we want to use every single time. Okay? So this is where you would start. Now, pause it if you would like. Try it again. Okay? Or let's continue and roll on. So what we know is that x is pi over 2. What we need is the y value. So if we plug in pi over 2, so let's think about that. If we go 0 to pi over 2, this is our triangle, and we want the adjacent over the hypotenuse, so the adjacent is 0. And if you want, you can throw your hands up. You have the 0, the 30, the 45, the 60, and then the 90. And if you put your finger down for that specific one, whatever it is, cosine is what's above it over the square root of 2, and sine is what's below it over the square root of 2. And that will work every time. So if you want the sine of 30 degrees, that's square root of 1 over square root of 2. Cosine, square root of 3 over 2. So it's always over 2. My bad. Sorry about that. Put your digits, and digits. So here's 0, 30, 45, 60, and 90. And it's going to be the square root of the fingers over 2 every single time. So if I want the sine of 30, put this one down, and it's the square root of 1 over 2. And then the cosine would be square root of 3 over 2. But if you want the 60 degrees, sine of 60 is the square root of 3 over 2, or cosine is the square root of 1 over 2. So it just depends on what you're looking at, okay? But you can always draw a triangle as well. So in our case, we're going to have y take away 0 equals dy over dx, x minus pi over 2. So now what we need is to fill in for this dy over dx. Well, we've got an equation. That is y is cosine of x. So we can take the derivative of that, which is negative sine of x. And when we do this, we're looking for the slope at that point. So we're really looking for dy over dx at negative sine of pi over 2. So that would have been, looking at this, these fingers, so there would be the 60, the 45, the 30, and the 0. So that would be the square root of 4 over 2, which is 2 over 2, which is 1. Okay, so that means dy over dx equals 1, but what's in front of it? Negative. So then we get y equals negative 1, x minus pi over 2, which makes it negative x plus pi over 2 equals y. Negative x plus pi over 2 equals y. All right. Number 3. Remember, pause again. They want the derivative of this function. Then unpause, go to this. It says derivative rule. We're going to change that. Rule of chain rule. Okay, so what I do when you hear the first rule, there's a list in our classroom that we run as we go. But the first rule of Fight Club is you don't talk about Fight Club. And I kind of made a list of rules of calculus that we need to follow. So the list of the chain rule is you have to take the derivative of the outside times it by the nested function. Okay? So as we work through this, we're going to take the derivative of the outside. And the outside is your power rule. So I'm going to have 2 times 2, the sine square root of x, and then that's going to go down by 1. But then we times it by the nested function. So the nested function is the sine function, as we do the outside. So the derivative of sine is cosine of the square root of x times, and why? Because we have another nested function. We have the square root of x, so that's going to be 1/2 x to the negative 1/2 power. So we clean it up. There's this and that, which cancel each other out. There's a sine of the square root of x. There's a cosine of the square root of x. And then there's a square root of x in the denominator. And we still have a 2 in the numerator. So if I were to give my final statement, hopefully we have 2 the square root of x, or 2 sine the square root of x, cosine the square root of x over the square root of x, which is letter D. I'd put my money on D. Okay. On to number 4. Oh, number 4, I think we're skipped for right now. And if you look, number 4, we did skip for right now. we're going to divide by long division, and we're going to take the integral based on long division. But we haven't learned it yet. So at this point, I don't want them to focus on this question because I don't want to stress them out. So let's go on to 5. 5, the function f is given by f of x equals 4x cubed minus x to the 4th. On what intervals is the graph concave up? So we design, pause. Concavity second derivative, pause. But our class makes a chart. And what we do is we do this. F prime, F double prime. And we talk about this one is increasing and decreasing, and max and mins. That's what the first derivative tells us. The second derivative talks about concave up, concave down, and points of inflection. So depending on what we need, like when the question asks what intervals is the graph concave up, that is telling us that we need to get down to the second derivative. And if we get to the second derivative, we want to know in that second derivative what values are positive. So this is what we're going to do. We're going to take our function and we're going to take the derivative. And that's going to be 12x squared minus 4x to the 3rd. And then we're going to take the second derivative. And that's going to be 24x minus 12x squared. And we're going to take the 12 out. We're going to have 2x minus x squared. And we're going to take an x out. And we're going to be left with 2 minus x. And we're going to take each one of those and set them equal to 0. And we're going to find 2 equals x and x equals 0 when we are all said and done. So what they teach you to use, not prove, but use, is a sign chart. So we have 0 and 2. So what we're going to do is we're going to take that second derivative, always focus on the function. When you are looking for answers in this sign chart, always look at the function that you used to get these values. So if I use the second derivative to get these values of 0 and 2, that's the one that I always want to plug it back into. So when we plug, like let's say number 1, we plug a 1 in there. I'm going to get 24 minus 12, which is going to give me, I don't care the number, just care about the sign. It's going to give me a positive answer. Okay? Give me a positive answer. Now, if I put in some huge astronomical number, let's talk about 1 million. Okay? If I put 1 million in, and I square it, I'm going to get a bigger million squared. And then I'm going to multiply it by 12, and I'm going to subtract it by just 1 million. Or 24 mil, which is a lot, but really when we square 1 million, we're getting way up there. So we know this answer, this side is going to grow exponentially bigger than this side. And if we're subtracting them, that means we're going to end up with a negative solution. So always bring it back to put a huge number in there. Like let's try negative 1 million. Wow, this time the negative 1 million is going to be squared, so it's going to become positive. You are correct. And then we're going to times it by 12, it's going to be a huge number. But what kind of 12? Negative 12. And we multiply it by a negative. So we have this negative 12 times this number that's squared, that always becomes positive, but then it turns it into a negative number. And then if we do 24 times negative 1 million, that's going to be negative. So a negative minus a negative just makes it a bigger negative. So now when they're asking on what intervals is the graph concave up, the only interval possible is from 0 to 2, because that's the only one that's possible. How do we feel about that? Hopefully good. And what they're looking for sometimes is these bad dads are points of inflection because it changes from concave down to concave up. Now, if we're going from a minimum to a maximum where we're going or we're decreasing to increasing, we would say that this is a minimum value if we were working with the first derivative. So I just want to give a little hint there. And then if we're increasing and then we go to decreasing, that would be a maximum value. So if we were looking at the first derivative, not the second, there's a difference. Second tells me concave up, concave down, and then points of inflection. But the first derivative would tell you increasing or decreasing, and then max and mins. Points of inflection are just points of inflection. Hope that didn't confuse anybody, but it comes up. All right, so what is dy dx at the point 2 comma 8? So it looks to me like we're just trying to take the derivative of the function. Oops, sorry, pause. Try it. Hint. Implicit differentiation, plug in point. All right, that sounds like good instructions. So we're going to, let's write the equation. X plus 3y to the 1/3 equals y. Okay. And let's take the derivative. If we take the derivative of x, that's going to be 1 at 1 derivative of x with respect to x. Plus, then we're going to multiply by 3 times 1/3 y to the negative 2/3 y dy dx equals 1, excuse me, dy dx. Because this would be 1y to the 0 power. Same thing here, it would be 1x to the 0 power. And then this is a 1, dx over dx, so 1 times 1 is just 1. Same thing here, 1 times nope, that's not the same thing. 1 times dy over dx is just dy over dx. And then we got this middle thing. Well, these at least clean it up a little bit. And I'm left with 1 over y to the 2/3 power dy over dx. Okay. Now, start to pull it out. Move it to the other side. Or you could move this however you want to do it. Whatever your brain is thinking. So I'm going to minus 1 over y to the 2/3. Ooh. No, I'm not. Let's make our lives easy. They give us a point. Let's plug that bad dad in. Do we have any x's to plug it into? No. Do we have a y to plug it into? Yes. So let's do that before we do anything else and make our life so much more difficult. So they pick numbers like this because what is the cubed root of 8? Well, that'd be a 2, Schmidt. Well, okay, so we have this. Okay. And what's 2 squared? Well, everybody's going to say, well, it's 1 over 4 now. dy dx equals dy dx. And then we can subtract 1/4 dy dx from both sides of the equation. We do that, we're left with 1, and we're left with 3/4 of a dy dx left. Because if we take 1 whole and subtract a 1/4, we still have 3/4 left. And then we're going to multiply it by 4 over 3 so that we can move it to the other side. And we get 4 over 3 equals dy dx. How did I do? Look at that. 4 over 3. Genius level. No, just kidding. All right, what we got? Two more left. Let's keep on rocking, baby. Number 7. Number 7, take the derivative. Ooh, yeah, I like this one because there's a couple things we could talk about. Pause it, try and solve it. The hint or tip, derivative rules. Yeah, paying attention to the derivative rules. Because what we really want to do is take the derivative with respect to x of x to the 5th. And we're going to subtract it and take the derivative with respect to x of 5 to the x power. And we can break it up into pieces because there's pluses and minuses between them. So I really kind of wanted to focus on that and really being able to break that up. But I also wanted to take a second to talk about this. Because this is where it kind of stems from. If you are familiar with the function e to the x, and we take the derivative of e to the x, everybody's going to yell and scream and go, it's e to the x. Yes, it is. Absolutely. But there is, just like the problem before, when we talked about this, and I kind of glazed over it a little bit, but we took the derivative of x with respect to x when we did this. Okay? But they won each other out, and at the end of the day, it doesn't matter, but that is what's happening. Well, there's something similar going on here. We're doing e to the x, but we're also doing ln to the base number. And the base number is e. Well, if we think about it, the ln of e just becomes a 1. And we've already talked about 1 times anything is whatever the thing we were multiplying it by. And that's why the derivative of e to the x is just e to the x. However, there's this underlying thing that no one, it's kind of that secret trade. And this is what they're trying to see is, do you know the secret trade? And so you are going to go, yeah, absolutely. It's 5 to the x ln of my base number, which is 5. And then the subtraction just gets brought down. And then this is just a normal power rule. And that should be our final answer. Which, boom, is there. Done deal. Just like we like it. All right, number 8. Yes, this is limits as approaching infinity. So limits and approaching infinity, we kind of had a little tutorial out in our parking lot, but you're going to see function races. And the function races means which function's going faster, because whatever function's going faster towards infinity is where we're ultimately going to end up. Now, if we have the same kind of issue going on the top and bottom, no one's going faster than the other one, so they end up canceling each other out, and you're left with the coefficient out in front. Anytime you are looking at this, always look and see if the powers are the same. Well, the powers of what? Well, it's actually the highest exponent. So when we look at this, we're looking at the highest exponent on the top and the highest exponent on the bottom. And going, okay, well, there we have it, but plug infinity in. And we're doing 2 different things. We're doing infinity squared, which isn't bad, but we're doing e to the infinity power. Just a little different. So I can take 100 and I can square it, okay? And that's going to give me 4 zeros, which is great. Or I can take that 2 to 100 power, and that's going to get astronomically huge really, really quick. Okay, so understanding that raising something to an exponent is going to go so much faster than just squaring. Okay, so when we see this, what that's telling me is that the denominator is going to win. So what happens when the denominator wins? 1 goes to 1, the other one goes to infinity. And when this happens and we get a 1 over infinity, means it's approaching 0. Because we're getting closer and closer to 1 over 100, 1 over 1,000, 1 over 1,000,000, 1 over a trillion, and we keep getting closer and closer to that x-axis. So as we do that, we know that this limit, even though there's not a value at it, but think about it, can you ever get to infinity? Should there ever be a value? No, but you keep approaching 0. Okay, so yeah, that problem we're not even doing, an area bounded by certain things. Not going to worry about that right now. So that is our beginning 9 questions. We are going to do 10 through 18 on Monday, and then we're going to do 19 through 27 on Tuesday through 36. Or, I'm sorry. So this will be Monday, this will be Wednesday, this will be the following Monday, and then the rest of them will go the following Wednesday. We broke it down, and if you look here, you can see a breakdown of it. Okay. So, if that's the case, like, feel free to look for, feel free to look for the 2019 practice exam, the international practice exam, and we're doing the MCQ for it. And that's where these problems are coming from. So if you want to push ahead, by all means. Otherwise, until next time, safe mathing. Questions? No questions.